Hello, welcome back to another video. Today we're going to be going through some questions and they're mostly going to involve force of interest, and we're going to be using force of interest to either find future values or present values and a whole bunch of stuff like that. So let's go start with question 1. Question 1 says the force of interest, delta t, is a function of time, and at any time t measured in years is given by that formula, which you can see here. And A says if 500 Rand is invested at t equals 2 and a further 800 is invested at t equals 9, calculate the accumulated amount at t equals 10. So let's start by drawing a timeline for this. So I'm going to draw time 0, time 2, time 9, and time 10. Okay. And it says 800 is, it says 500 is invested at time 2, so we're going to do 500 here, and 800 is invested at time 9. Okay. Now what I want to plot on my graph is our different forces of interest. So from time 0 to 3, so I'll mark this as time 3, our force of interest is going to be 0.05. Okay. And then from 3 to 8, it's going to be this, that's going to be our force of interest. So this will be 8. So in this period, our force of interest is going to be 0.09 minus 0.01 t. And then from 8 onwards, it's going to be this force of interest. So it's going to be 0.01 t minus 0.03. Cool. So that's our timeline all sorted. So now we want to find the value at time 10. So we want to find the value, future value at this point. So future value is equal to. So what we're going to have to do is we're going to have to move each of these forward to time 10. So I'm going to start with the 500, and I'm first going to move it from time 2 to time 3, because at time 3 the force of interest changes. So the way you move something forward when you have a force of interest is you multiply it by e to the power of integral from whatever time you're at, so from time 2 to time 3. So we're moving it from time 2 to time 3. And then in the integral, you're going to put your force of interest, which is 0.05 over this period, and then you'll do dt. Okay, so that's moved it from time 2 to time 3. So now we want to move it from time 3 to time 8, because that's where it changes again. So now we're going to times it by e to the power of the integral from 3 to 8, again of 0.09 minus 0.01 t dt. Cool. And now, so now we've moved it to time 8, now we just move it from 8 to 10. So we're going to multiply that by e to the power of the integral from 8 to 10 of 0.01 t minus 0.03 dt. Cool. So we moved it, we did that one jump, we did the second jump, and we did the third jump. So now this 500 has been moved forward. Now to the 500 we need to add 800 times, so the 800 is here, so we just need to move it forward for 1 year, so we need to times it by e to the power of the integral from 9 to 10 at that force of interest at 0.01 t minus 0.03. Cool, dt. So now we just need to evaluate all these integrals. So another way, instead of writing e to the power of something, you can write it as exp, which makes it a little bit easier because then you don't have to write everything as a power. So instead I'm going to write it as exp. We do the integral of 0.05, it's going to be 0.05 t evaluated from 2 to 3 times exp of 0.09 t minus 0.005 t squared from 3 to 8. Cool. Times exp 0.005 t squared minus 0.03 t from 8 to 10. Cool. So I think you should probably be able to do these integrals quite easily. That's quite simple. And then we can't forget our last one, so plus 800 times x of 0.005 t squared minus 0.03 t from 9 to 10. Cool. So now we've done all that integration. So when we plug this into our calculator, we're going to get 500 times e to the power of 0.05. So basically you just sub in 3 and you minus when you sub in 2. So normal integration should be pretty easy. Times e to the power of 0.175 times e to the power of 0.12. Okay, so basically this comes from that one, this one comes from that one, this one comes from that one. Plus 800 times e to the power of 0.065. And when we write that out, we get 705.995 plus 853.727. And when we add it up, we get 1,559.72. That's how you do A. Okay, cool. Next, we're going to have a look at B. So B says, determine the constant effective interest rate per annum to the nearest 1%, which would lead to the same result as in A being obtained. Okay, so now imagine we had a constant interest rate over the whole period. How would we get the same future value? So the way I'd work it out is your future value, which is equal to 1559.72, would be equal to, so using the interest rate, we'd move this 500 forward to time 10. So that's 8 years. So it would be equal to 500 multiplied by 1 plus I. So it's from time 2 to time 10. So we're going to move it forward 8 years. Plus 800 multiplied by 1 plus I. We're moving it forward 1 year. Cool. So it's about 1. Okay, so again, we could do this using linear interpolation. But another way you could do it, which I'm going to show in this video, is we're going to use our financial calculator. So I've actually got a little picture of it here just to show you which buttons to press, and I'll write it out on the side as well. So this is the HP12C calculator that you can use. So let me write the steps here to solve this. So basically we have this as our whatever future value, which we can call it, and we'll have these as our like 2 payments, and they should equal. So step number 1, you're going to say cash flow 0 is going to be equal to minus 500. Okay, so basically we're going to say that these 2 500s are payments, and then this is going to be our positive thing. So you just need to make sure one, like either these or these have to be negative. So I'll make these negative. The way you do it is you just press 500, and then to make it negative, you do change sign. That's how you'd get negative 500, and then you'd say, so you'd get like 500, change sign, and then you'd say, press the G, and then you'd say cash flow 0, and that would give you 500 as your cash flow 0. Okay, step number 2, you want, so we have our cash flow 0 is 500. So now we have a lot of years where we don't have any payments. So like time 3, we didn't pay anything, time 4, time 5, time 6, time 7, time 8. Okay, so we could do it all manually, but there's a shortcut we can do. So we can say cash flow J equals 0. So the way you do it is you'd say 0, enter, and then you'd say G cash flow J. That basically says like the next cash flow is going to be 0. And then if we want to do a lot of zeros, then we can do NJ equals 6. That means basically the next, including this one, the next 6 will all be 0. So you press 0, enter, and then you press G, NJ. So that basically means, I'm going to write it out on our thing just to show you what I'm kind of doing. 5, 6, 7. So basically we're doing 0, here's 0. I'm making these negatives as well. And then here we have like positive 1559.72, 1559.72. So we have 0, 0, 0, 0, 0. Here, if we count them, we have 1, 2, 3, 4, 5, 6. So I put in negative 500 as our first cash flow, and then I put in 6 zeros. Okay, so it makes sense. So negative 500, and then 1, 2, 3, 4, 5, 6. Okay, and then our 9th one is going to be negative 800. So now what we're going to do is we're going to say cash flow J is going to be negative 800. So again, the way you do that is you'd put in 800, and you'd press change sign to make it negative, and then you press G cash flow J. Cool. So now we've entered all of our cash flows. Oh, sorry, we haven't. We still need to enter in our final one. So this will be our final future value cash flow. So we're going to say cash flow J equals 1559.72. Okay, so we've entered in all our cash flows. So basically, these are all our cash flows. So it's negative 500, you have 6 zeros, negative 800, and then you have this positive one. And then what you're going to do to get our final answer, you press IRR, okay? Internal rate of return. So you're going to press F and then press this one. It'll give you the internal rate of return, which is the interest rate. And if you entered everything correctly, you should get 4.7017. And the answer to always to returns you as a percentage, so that you can have that as your percentage. Cool. So this is how you do this question using a financial calculator. Feel free to also do this using linear interpolation, but I thought I'd just try a different method for this video. Okay, now we can have a look at question 2. Question 2 says the force of interest is given by a function. So again, we have another function. It's this between 0 and 5 and this from 5 onwards. And A says derive and simplify as far as possible expressions for Vt, where Vt is the present value of a unit sum of money due at time t. So let's start by drawing out a timeline. So 2a. So from time 0 to time 5, it has this force of interest. So delta is equal to 0.04 plus 0.02t. And then from 5 onwards, it has the force of interest rates of 0.05. Okay. And now they want the present value, so the value at time 0, of a sum of money at any point. So we're going to have to break it up into a few cases because the force of interest changes, obviously. So the first case is going to be between 0 and 5. Okay, I'm going to say if t is between 0 and 5. Okay, so now the present value, which is Vt, is going to be, so again, so before when we were accumulating, we did e to the power of the integral of whatever. Now we're going to do e to the negative integral because we are discounting. So when we're discounting, when we're moving backwards, we always put a negative here. So it's going to be e to the negative integral from 0 to, so we don't know exactly where t is, but we know it's between 0 and 5. So we're just going to go to t, and we're going to put this in. But since we have a t up here, we should change the letter of this just so that we don't get confused. I like to use a k because you're supposed to use s's, but my s's look like 5s. I'm going to use a k. So I'll do 0.04 plus 0.02k dk. Okay. And then we're just going to evaluate this integral, and that'll be our present value. So it's going to be x of the integral, so 0.04k plus 0.01k squared, evaluated from 0 to t. And that's going to give you, forgot the negative here, negative. And that's going to give you negative 0.04t minus 0.01t squared. Cool. So if t is between 0 and 5, your present value of a unit sum of 1. So when they say a unit sum, they mean like an amount of 1. So let's say at like time 4, we invested 1, which means multiplying this all by 1. Cool. Okay, so now we're going to have to look at the case if t is greater than 5. So if t is greater than or equal to 5. Now let's have a look. So this one's slightly more complicated because t is past here. So t could be somewhere here. But we know we're going to have to discount this whole 5 at least. So the way I like to do it is I'm going to write Vt is going to be V5. So this represents us discounting it from this point from 5 onwards because we know we're definitely going to be at least past 5. And then we're going to have to discount a little bit further because we're going to have to be discounting like this, whatever this point is, we're going to have to discount to 5 and then an extra 5. So this will be e to the power of negative integral from 5 to t, because we don't know exactly where we're starting from. We'll call this t, so we're discounting from like t to 5 at the rate of 0.05 dk. Cool. So this is quite nice because we can use this formula for discounting for 5. So we can basically just sub in 5 for this one because we worked out in the previous question. So we can write that as, if we sub in 5, we'll get negative 0.2 minus 25. So it'll be e to the power of negative 0.2 minus 0.25. Cool. Then times, so that's basically goes to that one, times x. Do the integral of this. It will be 0.05k. And this gives us e to the power of negative 0.45. I should put in my bounds here from 5 to t. Okay, so we sub in t, we get e to the 0.05t. And when we sub in 5, we get e to the negative I forgot my negative here as well. So this should be negative, negative, yep. And then this should be positive 0.25. Okay, I hope that all makes sense. Sorry, I messed up the negatives a little bit there. Okay, cool. So now if we just combine these two, we're going to get e to the power of negative 0.2 minus 0.05 t. And that's going to be your final answer. So if t is in this range, this is going to be your discount. And if t is in greater than 5, that's going to be your discount. And that's 2a. Okay, let's have a look at B now. B says calculate the present value of 1,000 Rand due at the end of 17 years. Okay, so we want the present value of 1,000 Rand due after 17 years. And the great thing we worked on the previous question is we worked out the present value of 1 Rand at any time. So all we have to do is we have to multiply that thing that we just worked out by 1,000 because we're doing it for 1,000 Rand. So we're going to do 1,000 Rand times V of 17. Cool. And 17 is clearly greater than 5, so we use this formula. So we're basically just going to sub in a 17 to that formula. So it's going to be 1,000 times e to the power of negative 0.2 minus 0.05 times 17. And when you plug that all into your calculator, you should get 349.94. Okay, pretty easy first one. Now let's have a look at the second one. The second one says, calculate the rate of interest per annum, convertible monthly, implied by the transaction in part B. Okay, so let's draw it on a timeline. So at 17 years, we had 1,000. And when we discounted it back, which we just did in the previous one, we got 349.94. Okay, so we can write in a little equation and basically instead of using force of interest, we can use interest rate convertible monthly. So what I'm going to do, I like discounting forwards. I like accumulating forwards. I'm going to basically accumulate this to be 1,000 and see what interest rate that implies. So I'm going to do 349.94. So if we are doing like interest rates, annual interest rate, we would just multiply by 1 plus I to the 17. But since we're doing interest rate monthly, we're going to have to multiply by 1 plus I 12. So that's your normal interest rate convertible monthly. You have to divide it by 12. So this gives us the effective interest rate per month. But now we have to raise it to the power of how many months instead of how many years. And there's 12 months in a year, so we can do it to the power of 12 times 17. And that's going to give you 1,000. Cool. So now to solve for I12, which is what we're overall aiming for, we're obviously going to divide both sides by this. We're going to put it to the power of 1 over that, minus 1, and multiply by 12. So that should be pretty easy. This is just like solving an equation. We're going to say 1,000 over 349.94. Obviously, it's going to be to the power of 1 over 12 times 17, minus 1, and then times 12. And if you put that into your calculator, you get 0.06192, which is roughly 6.19%. And that is your normal interest rate convertible monthly that's implied by this transaction. And that's the end of question 2. Cool. Now let's have a look at question 3. So question 3, again, we have a force of interest which is different over different time points. And A says calculate the present value of a unit sum of money due at time 25. Okay, so timeline's really helpful for this one. So we have time 0 and we have time 25. And the interest rate changes at time 10 and time 20. Okay, so over this period, we can see that delta is equal to 0.05. Over this period, we can see that delta is equal to 0.006 t. And then from there onwards, we can see that delta is equal to 0.003 t plus 0. Let me just move this along to give me a bit more space. 0.0002 t squared. Cool. And basically we're basically like, we want to discount R1 all the way back to time 0. Okay. So the present value is going to be, so let's first do it from here to here. So it's going to be e to the, since we discounted, it's going to be negative integral from 20 to 25 at 0.003t plus 0.0002 t squared dt times, okay, so now we're going to do it, so now it's been discounted there, so now we want to discount it from 20 to 10, so times e to the negative integral from 10 to 20 of 0.006 t dt. Okay, so now it's discounted to 10, and now you just need to discount it from 10 to 0. So times e to the power of integral negative from 0 to 10 of 0.05 dt. Cool, now we just need to solve all these integrals and we'll be done. So it'll be x of 0.0015 t squared plus 0.0002 over 3t cubed, evaluated from 20 to 25, times x of 0.003 t squared, evaluated from 10 to 20, times x of 0.05t, evaluated from 0 to 10. Okay, that looked good to me. Oh, I've got all my negatives, because remember, all of these are negatives. So just remember, negative here, negative here, negative here. Yeah, okay, now it looks good. So now all we need to do is sub this, so sub these in. So basically sub in 25, and then it's just the way you normally evaluate integrals. So you sub in 25, and then you minus when you sub in 20. So you sub in like negative 20. So you minus when you sub in 20. So yeah, so like, for example, I'll do this one. So it'll basically be like, I won't write it up because it's very easy, but it's just basically like 0.05 times 20 minus 0.05 times 0. Times 10 for this one, and then times 0. Yeah, very good. Cool. That should be quite easy to evaluate these. And when I plug it into my calculator, I'm going to get e to the negative 203 over 240 times e to the negative 0.9 times e to the negative 0.5. Okay. And that will give you e to the negative 539 over 240, which if we like make it a decimal, it becomes 0.1058393. Okay, so basically if you present value this 125 years with all these forces of interest, it's going to be about just like 10.5 cents. Or 10, yeah, about 10 cents. Cool. So that's A. Okay, now let's have a look at B. What does B ask us to do? B says, calculate the effective rates of interest per time unit from T19 to T20. Okay, effective rate of interest. So what we probably want to do is we probably want to find the future value of R1 from time 19 to 20, and then use our formulas for like, then we just basically, yeah, so let's start with that. So future value, if we have a unit sum of money at time 19, it'll be e to the power of 19 to 20 at the interest rate of 0.006t dt. Okay, so that's going to give you x of 0.003t squared from 19 to 20, which is going to be e to the power of 0.117, which is 1.12411194. Cool. Okay, so now I'll show you the reason why I did this. So now if we draw a quick little timeline. So at time 19, we had 1, and then I future valued 1 to time 20. and at time 20, we had 1.12, blah, 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 okay? And now the question's asking, calculate the effective rate of interest, okay? So to find the effective rate of interest, we can basically say that 1 multiplied by 1 plus I, because this is how we do it if we had interest. If we moved it forward 1 year, just be 1 plus I to the power of 1. And we'd say that that's equal to 1.12411194. Cool. So to solve for I, it's very easy, because this is just multiplied by 1 to the power of 1, so we just minus 1 from both sides. So we get I equal to 0.1241, let's round it here, 2, which is roughly 12.41%. Okay, so this was a little bit tricky to understand maybe, but all we did was we feature valued using our force of interest from time 19 to 20. And we found that if we feature valued it, we got like 1.2. And then using our interest rate, we could easily find that the interest rate is 12.41%. Perfect, and that's question 3 done. Let's have a look at question 4 now. Question 4 says, Sibongile makes deposits of 100 Rand at time 0 and X at time 3. The fund grows at a force of interest of T squared over 100. The amount of interest earned from time 3 to time 6 is also X, calculates X. So we get a lot of information, so whenever we do that, we can draw a timeline. So we have the important times at time 0, time 3, and time 6. So she makes a deposit of 100 Rand at time 100, and then another deposit of X at time 3, okay? And over the whole period, let's note this down, over the whole period, the force of interest is, I'm gonna write it like this, 1 over 100 T squared. Okay, any other interest? Okay, then they also tell us that the interest earned from time 3 to time 6 is also X. So over this period, the interest is also going to be X. Cool. So I think the best way to solve this question is we're going to want to accumulate this 100 to time 3. So that'll give us the value at time 3. And then we want to accumulate that whole amount to time 6. And then what we're going to do is we're going to take the accumulation at time 6 minus the accumulation at this point, and that's going to be the interest, right? Because whatever the difference is between this point and this point is whatever we earned in interest. So we're going to take the accumulation at time 6 minus the accumulation at time 3 and let it equal to X. And then from those equations, we can probably solve for X. So let's start with the easy one. The value at time 3. Value at T3. Cool. So the value at T3 is we're going to want to move this 100. So we're going to move it forward. So it's going to be integral but positive, because remember, positive is to move it forward from 0 to 3 at the rate of 1 over 100 T squared dt. Okay, so that'll move this 100. But remember, at T3, we also have this X. Then we'll just be plus X. Okay, so it's going to be 100 times exp of, if we do the integral, it becomes 1 over 300 t cubed from 0 to 3 plus x. And if we sub this all in, we get 100 times e to the power of 0.09 plus x. Okay, that wasn't too bad. So that's basically the accumulated value at this point. So now we want to take all of that and move it forward another 3 years. Okay. So value at T6 is going to be, we're going to take the whole amount, so it's going to be 100 times e to the 0.09 plus x. So we take this whole value and we're going to move it forward 3 years. So times e to the integral from 3 to 6, because we're moving from 3 to 6 at 1 over 100 t squared dt. That's going to be 100 e to the 0.09 plus x multiplied by x of 1 over 300 t cubed evaluated from 3 to 6. And when we sub this in, we're going to get 100 e to the 0.09 plus x multiplied by e to the power of 0.63. Okay, so now we've got the two things we wanted. We wanted the value at 3, the value at 6. And now what we're going to do is we're going to take this value and minus this value, and that's going to give us the interest, right? So the interest between T3 and T6 is equal to x, right? And that is all going to be equal to, so we take the value at T6, which was this one. So it's going to be 100 e to the 0.09 plus x times e to the 0.63 minus, we take the value at T3, which was this one. So minus 100 e to the 0.09 plus x. Cool, so now we have an equation because you know this is all equal to x. Cool. We also just need to remember to put this in brackets because we're minusing the whole thing, so we're minusing this whole thing. Okay, so now what I'm going to do is I'm going to multiply out all the brackets. So I'm going to get 100, if we add those up, it's going to be e to the 0.72 plus x times e to the 0.63 minus 100 e to the 0.09 minus x equals x. Okay, so now we want to solve for x. I'm going to bring everything with x to one side, so I'm going to bring all the x's to that side. So I'm going to have x, when I move this across, it's going to be plus x minus x times e to the 0.63 equals 100 times e to the 0.72 minus 100 e to the 0.09. Okay, I'm going to factor out an x. So if I factor out x, I'm going to get 2 minus e to the 0.63, and that's obviously going to just equal that. Minus 100 is 0.09. Okay, now we just divide both sides by this. So I get x equal to 100 e to the 0.72 09 divided by 2 minus e to the 0.63. And when you sub that into your calculator, you get x equal to 784.59. Perfect. So the amount that she added here and the interest must be equal to 784.59. And that's all of question 4. Okay, finally we're going to have a look at question 5. And this one's quite a long one, so lock in. So question 5, again, we're given a force of interest. And it says, what is the total accumulated value at any time of investments of 100 Rand at time 0, 6, 4, and 6? So we're investing 100 Rand at those times, and we want the accumulated value at any time. So this is a very classic exam question, so pay attention. So let's draw a timeline. And we want to mark all our important times. So I'm first going to mark the times where the force of interest changes. So time 0, time 5, and time 10. Okay. And then we make investments at 4 and 6 and 0. Okay. So we invest 100 Rand here, we invest 100 Rand here, and we invest 100 Rand here. Cool. The force of interest is constant in that period. It is delta is equal to 0.07 minus 0.005 t. Okay, from 5 to 10, delta is equal to 0.06 minus 0.003 t. And from 10 onwards, delta is equal to 0.03. Cool. That's all our important information. So now, all the time points I've marked, I like to think of them as like your critical points, and we're gonna basically like mark it into different sections between all of these points. So we'll start with between 0 and 4. So if t is between 0, and we must not include 4, because that's when you deposit 100, so not including 4. Cool. So if t is not including 4, all we have to do is we have to move this 100 forward to some time t, which we don't exactly know. So your accumulated value is going to be 100 times, you're going to do the integral, e to the power of integral, from 0 to t, and it's going to be at the rate of 0.07 minus 0.005t. We should do k. dk. Cool. That makes sense. Okay, so we're basically moving this 100 forward to some time t. Okay, so if we do the integral of this, 100x, and it's going to be 0.07k minus 0.0025k squared from 0 to t. And if we sub that in, we're going to get 100 times e to the power of 0.07t minus 0.0025 t squared, because obviously when you sub in the 0, it's going to just make it 0. Cool. So that's your first interval. I'm going to enable it. That's interval 1. So that's between 0 and 4. So now let's do our second interval. So this is if t is greater than or equal to 4, but less than 5. Okay. So basically this is this interval now. So now what we have to do is we've moved this 100 forward here. Now we have to move that 100 forward another 1, and we have to move that 100 forward. So let's start with our first one. So it's basically going to be, so your cumulative value, it's going to be, let's start with, this 100. So it's basically going to be 100 times x. So we're going to have to move it forward from time 0 to time t, but now t can be like greater than, so it'll be 0.07 minus 0.005 k dk. Okay, that's basically we're moving this 100 forward now to like here somewhere, for example, to t here, and now we have to move this 100 forward from time 4 to time k to time t. Okay, so that's moving the first one. We need to add 100 times x integral. So now it's not from 0, it's from time 4 to time t. So we're moving this one from 4 to t, which is some arbitrary point here. Okay, and 0.07 minus 0.005k dk. Okay, so this looks exactly the same as what you did in the first one, so we can actually just keep that. So that first one is going to become 100 times e to the 0.07t minus 0.0025 t squared. Cool. We're just going to add the second one. So the second one is 100x. If we do the integral, it will be 0.07k minus 0.0025 k squared from 4 to t. Okay. And when we sub that in, we're going to get 100 times e to the 0.07t minus 0.0025 t squared. When we sub it in, it's going to be plus 100 times e to the power of 0.07t minus 0.0025 t squared. But then we also, when we sub in the 4, we're going to get something, and we're going to get minus 0.224. Okay. So now we want to simplify this a little bit, so we can you can see that these look the same, right? So we can basically factor that, and 100 is also the same, so we can factor the 100. So we can factor 100 e to the 0.07t minus 0.0025 t squared, and we're going to be left with 1 plus e to the negative 0.24. So basically just factored like that and that. Cool. That's good. Okay, and now if we multiply that and that, because those are all like the constants basically, we're going to get 178.66 times e to the 0.07t minus 0.0025 t squared. Okay, and I'm just going to store this in our calculator as a, because I don't want to write out all the decimals, but I do want to get it quite accurate. So I'm going to store that as a in my calculator. Okay, so that's the second interval. I know it's quite long. I told you it was going to be quite long. Cool, so we've done the second interval. Now we need to do this third interval from 5 to 6. So number 3. Let's do it in white. Number 3. If t is between 5 and 6. Okay. So we accumulated value. Okay, so we already know the accumulation up until here. So all we need to do is we basically need to sub in 5 into our previous one and then accumulate that to times 6. Okay, that's not too bad. So the accumulated value is basically going to be, I'll say your accumulated value at time 5 times, now we want to move it forward to some arbitrary point between 5 and 6. So I'm going to say times the integral from 5 to t. So we're moving from 5. So what this AV5 does is moves all of this to time 5. And now we're moving it forward from time 5 to time arbitrary point t. Okay. So from time 5 to time t of 0.06 minus 0.003 k dk. Okay, because remember we have to use this new rate now. So instead of using this one, I'm using this one. Cool. That all looks good. So AV at 5 is, we can take this one and just sub in 5 for t, because this works for any points from 4 to 5. So it'll basically be, I'm just going to use the letter, so a times e to the 0.07 times 5 minus 0.0025 times 5 squared, cool, times, do our next line, times x of 0.06k minus 0.0015 k squared, evaluated from 5 to t. Okay, good stuff. And from that, I'm going to get a multiplied by e, so this will all simplify to 0.2875. Okay, and we sub in t, we're going to get e to the 0.06 t minus 0.0015 t squared, and we sub in 5, we're going to get e to the negative 0.2625. Okay, now what I'm going to do is multiply all these constants together, and that'll give me 183.19 times, and then the e part with all the t's, so 0.06 t minus 0.0015 t squared. And again, I'm going to save this as b just for future calculations to get it accurate. Okay, cool. So this is our formula for the accumulated value for any t between 5 and 6. 5 and 6. Okay, cool. Okay, now we need to look at our fourth interval. This is if t is between 6 and 10. Okay, so we have the interval from 5 to 6. So again, what we can do is we can take our formula and move it to 6, and then move that to an arbitrary point t. But then we mustn't forget about this other 100 as well. So let's start with that first one. So your accumulation in value is going to be your accumulation in value at time 6 times x of, we want to move it from time 6 to time some arbitrary point t of 0.06 minus 0.003k dk. Okay, that's good. And then we also have to move this 100, because remember at time 6 we're depositing another 100. We have to move that 100 from time 6 to time t as well. So we have to move that 100x, we move it from time 6 to time t at that rate, 0.06 minus 0.003k dk. Cool. So to get the accumulated value at time 6, it's going to be b, because we're going to use this formula, because this formula gives us the accumulation at any time from 5 to 6. So we're just going to sub in 6 to this formula. So it's going to be b times e to the 0.06 times 6 minus 0.0015 times 6 squared. Okay, so that's 8. That is basically that. And that's going to be multiplied by exp. Let's do the integral quickly. So it'll be 0.06k minus 0.0015k squared from 6 to t plus 100, and it's going to be exactly the same integral. Probably getting quite sick of these by now. 0.06k minus 0.0015k squared, evaluated from t to 6. Cool, good stuff. So this will give us b times, this all simplifies to e to the power of 0.306. When we sub in the t into this integral, it's going to give us e to the power of 0.06t minus 0.0015t squared. And when we sub in 6, but make it negative, it's going to be, so we sub in 6, but then we multiply the whole thing by -1, and it's going to give us negative 0.306. Cool. So that's all of this for the top part. But now we also need to do the one for the second part. So it'll be plus 100 times, when we sub in t, we're going to get e to the 0.06t minus 0.0015t squared. And when we sub in 6, we're going to get e to the negative 306. Okay, so the first thing that's quite nice is that and that cancel. So we get that. And then what I'm going to do is I'm going to actually factor out this. And then we'll be left with, so I'm going to factor out e to the 0.06t minus 0.0015t squared. And we're going to be left with b plus 100 times e to the negative, well, it should be 0.306. Cool. And when we multiply, when we simplify this using our calculator, we're going to get 256.82 times e to the 0.06t minus 0.0015t squared. Okay, and once again, I'm going to save this in my calculator as c for future. Okay, we're almost done. So that was the interval from 6 to 10. Final interval from 10 onwards. This one actually shouldn't be that bad. So, fifth interval. If t is greater than or equal to 10. So this accumulator in value is going to be, so again, we're going to use the same trick as we did in the previous ones. We're going to move it forward to time 10, and then we're going to multiply all of that. So we're going to say it's going to be the accumulation up until time 10 using this formula. And then we're going to multiply that by moving it forward from time 10 to some arbitrary point t. At the rate of, what was the rate? 0.03. Ah, nice easy one for us. 0.03 dk. Cool. So it's going to be, the accumulation value at time 10 is going to be, using that formula, it's going to be c times e to the 0.06 times 10 minus 0.0015 times 10 squared, all then multiplied by exp of 0.03k from 10 to t. That's going to simplify to c times e to the, this simplifies to 0.45 times e to the 0.03 t, we sub in the t into this one, and e to the negative 0.3 when you sub in 10 and then times -1. Cool. So if we multiply all the constants, so if we multiply that, that, and that, we're going to get 298.39 and times e to the 0.03 t. Okay, and that's our fifth interval. We are finally done with this question. So we got this interval if it's between 0 and 4, that's our answer. We got this if it's between 4 and 5. We got this if it's between 5 and 6. We got this if it's between 6 and 10. And we got this if it's 10 onwards. So I think the key to this question is just taking it slow, doing it interval by interval, and drawing a number line really helps because then you see where things change. So either things always change when you deposit, or when the force of interest changes, and that's going to help you break up your timeline into different sections. Cool, that's the end of the video. I know some of the questions were quite a slog with a lot of like finicky little things, but I hope you enjoyed it and I hope you found it useful, and I'll see you in the next one. Goodbye.